Hi, in this video, I'm going to introduce RSTP, Rapid Spanning Tree Protocol. So as we talked about in a previous video, one of the disadvantages of traditional spanning tree is convergence. As we saw with those timers, it can take anywhere from 30 to 50 seconds for the network to converge. Rapid spanning tree helps with this convergence that tends to plague STP. Now, rapid spanning tree is applied on Cisco switches as a single instance per VLAN. That's known as rapid PVST plus. Rapid per VLAN spanning tree plus, which is the default on most Cisco switches. There's also another more advanced feature, which is the 802.1s multiple spanning tree. We talked a little bit about both of those in previous videos. Okay, the port states in rapid spanning tree. So it's a little simpler than with regular spanning tree, as we really only have 3 states. We have discarding, where frames are dropped, no MAC addresses are learned. It's a combination of regular spanning trees disabled, blocking, and listening modes, or states, excuse me. There's the learning state. Okay, this is where incoming frames are dropped, but the MAC address table is updated. And this is equivalent, again, to the learning state in regular STP. And then there's the forwarding state, which is the same as the forwarding state in traditional STP. So we only have 3 states in rapid spanning tree. Okay, as far as the convergence process, it's the same. There's still the same 3-step convergence process that we've seen before, and decision making. The root bridge is still elected the same way. But let's take a look at some of the ports. Similar to regular 802.1d traditional spanning tree, there's a root port. And that's the one port on each switch that has its best path to the root bridge. So we've seen that before. There's the designated port, which is the same as the designated port on a traditional spanning tree. It's the switch port on that network segment that has the best path to the root. There's the alternate port. That's the same thing as the blocked port or the non-designated port that we've seen in regular spanning tree. Okay. And there's a note there, mention of Cisco uplink fast. I won't go into that here. Maybe in a later video, I'll talk about some of the Cisco enhanced features. There's also something known as a backup port, which is also a blocked port in traditional spanning tree. This isn't very common. This is really when your switch is connected to a hub. We'll see that here in the next slide. So in this slide here, we can actually see some of the different ports here. So we've got this switch here is the root bridge. So both of its ports are going to be designated ports. Okay, this switch here has set this as the root port, and this is the root port because these ports have the best path to the root bridge. Okay, similar to traditional spanning tree that we saw in other videos, because this switch here has better point to it, there we go, this switch here has a lower sender bridge ID. It becomes the designated port, so is forwarding. And this port over here becomes the alternate port discard, so it goes into blocking mode. This is where we can actually see our backup port. So we have a hub down here, and this port here actually goes into backup, and this one will be the designated port. And it actually does that similar to what we've seen in our decision-making process. This is the lowest port ID. Okay. All right, so that's kind of an example of some of those ports. Not too bad. Once you learn traditional spanning tree, it's very similar to rapid spanning tree, or rapid spanning tree is very similar to traditional, I should say. Okay, rapid spanning tree. So we said that the advantage of rapid spanning tree was all about convergence, and that's because faster convergence. And that's because rapid spanning tree takes a slightly different approach. When a switch, it joins the topology powered up, connected, or whatever, or detects a failure in the existing topology, it determines its forwarding state based on the type of port it is and the link type. So without going into a lot of detail, but it's important to recognize what these ports are and these link types. So an edge port immediately transitions to forwarding state. An edge port is similar to what I've mentioned in previous videos and have another video on called the STP port fast feature. So we can do the same thing in traditional spanning tree with the port fast feature. And actually, just so you know, it's the same command to configure it either in traditional spanning tree or rapid spanning tree. But it never generates what we call topology change notifications. That's a kind of a different subject here, more than I want to go into here. But it doesn't cause any kind of reconvergence when a device is attached to an edge port. So edge ports, as you can see here, here's some edge ports, right? This is where we have a non-switch, an end user device attached. As we can see here, these are all non-edge ports because there's another switch attached. Okay, so that's the difference between an edge port and a non-edge port. And again, one of the big benefits of this is that it immediately transitions to forwarding state. Doesn't go through any of the timers, the forwarding delay timers, or any of that. As soon as the device is connected, it can start forwarding. Why is that a good thing? Because that way, when this device is connected and sends out, let's say, a DHCP offer, it can immediately be forwarded by the switch to the DHCP server. All right. Okay, so some of the ports here, root port, we've kind of already talked about. We can see, let me get my pen here. Here's our root bridge. We have a root port here, right? Okay, that's nothing new there. Best path to the root bridge, one per switch. Okay, couple of different link types. By the way, there's edge ports, we've talked about them, alternate ports, which was the discarding port. Okay, as far as link types, we have a couple of different link types. Point-to-point link types. Point-to-point link types operate in full duplex mode. It's when where there are two switches interconnected. So where do we have these point-to-point links? Well, we have one right here. This is a point-to-point link. This is a point-to-point link, and this is a point-to-point link. What about this? Well, that's a hub, not a switch. So it's not going to be a point-to-point link. We'll get there in a moment. But I sometimes show this in my CCNP class, but there's a quick handshake that's done between these two switches that can quickly determine whether or not it's designated port, root port, alternate port, or whatever, and speed up the convergence process. Okay, so let's take a look at this last one here, this last port type, and that's the shared medium port. This is a port operating in half duplex, okay? So the half duplex here, this would be a shared medium port. Why? Because there's a hub here. And with a hub here, that means there's a possibility that we could have multiple switches attached. Okay? So that's known as a shared medium port. Okay, I hope this helps introduce you to rapid spanning tree protocol. It's actually the default now on Cisco switches.